When we checked out my website with Chrome's DevTools in the previous module, we saw that the HTTP request sent by the browser contained a set of headers. And so did the HTTP response sent back from the server. These headers allow passing additional information with each request or response. An HTTP header consists of the header name, which is case insensitive, followed by a colon and then by its value. If multiple values, or strictly speaking parts of one value, can be set, use a comma to separate them. The headers of a request contain more information on the resource to be fetched, or about the client itself. It's the responsibility of the client, be it a browser or our HTTP client instance, to provide these. We'll encounter a few of these throughout the course, but a common request header we will immediately use in the next demo is accept. This tells the server the media type the client is willing to accept. For example, application JSON, or which you see in the second example, preferably application JSON, and if that's not available, then return text HTML. The headers of a response then contain information on the generated response or server. These are thus typically generated by the API, and they tell the client, for example, how to deserialize the response. That is what the content type header is for. It provides the media type of the response body. For example, application JSON. A lot of headers, most even, are optional. Yet, it is important to be as strict as possible to improve the reliability of your requests. For example, that accept header we just mentioned is often not set. But it is an obligatory header in RESTful systems because it improves reliability. If we would have set an accept header value in the previous demo when we sent a request, our application would not have crashed. The mechanism that's at work here is called content negotiation. It's a mechanism used for serving different representations of a resource at the same URI. Let's elaborate on that a bit. Any resource, like our list of movies, can have different representations. For example, the API can provide our list of movies with a JSON representation, but it could also want to provide them as an XML representation. This is still the same resource, the movies resource, but the representation is different. It's JSON or it's XML. What content negotiation does is allow the client to tell the API which representation is best suited for it. It does so by passing through the media type via the accept header. If it passes an accept header with value application JSON, the API should return a JSON representation. If the value is application XML, the XML representation should be returned. Accept is one of the headers used in content negotiation. Others are accept encoding for the encoding, typically used when working with compression, accept language for multi-language support, and accept charset for working with different character sets. Let's check out that accept header in the next demo. In this demo, we will learn how to manipulate the request headers. We previously learned that there were additional configuration options on our HTTP client instance. One of these is the default request headers collection. As the name implies, we can use this to set some default header types and values to be added to each HTTP request. Currently, no default request headers are set, yet it is a good idea to call clear on this collection first. I tend to do that just in case this collection has been manipulated by other parts of our code. If we look at the default request headers collection, we see that there's quite a few headers we can set. Accept charset, accept encoding, accept language, and so on. We are interested in adding a new accept header. We do that by calling add on the accept collection. This expects a new media type with quality header value, which is a class that represents a media type as a string and potentially a relative quality factor. We'll get to that. We want to send a request that tells the API we only accept application JSON, and that's what we achieve by adding this accept header. Let's give this a try. And there we go. Our code works again. We get back JSON even though our API defaults to XML, and that results in the JSON deserialization working again. Let's get back to our code. Default request headers.accept is a collection, which implies that we can tell the API that we are willing to accept multiple media types. That can be achieved by adding those to the accept collection. For example, if we add application XML again, the API will revert to its default option and give us back XML, as we are now saying that we are willing to accept JSON and XML. If we run our code now, we would crash again, because we are still assuming that we're getting back JSON. So, to deal with scenarios like this, we need to add some additional code. If we are willing to accept both media types, we must also ensure that we can deserialize both response bodies. As we learn on the slides, the content type header signifies the format of the message body. So we can inspect that header to know how to deserialize. So instead of simply using system.text.json for any response body, we check the media type of the content type header. If it's application JSON, we use system.text.json, and if it's application XML, we use an XML serializer. We've still got our breakpoint set here from the previous time we launched, so let's give this another try. Let's have a look at the movies variable. And there we go, that worked like a charm. In other words, content negotiation, as we learn on the slides, is an important concept to keep in mind when building reliable applications. Supporting multiple media types can be useful to minimize client-server interaction when content negotiation fails for a specific type when a client supports different media types. And this brings us to that relative quality factor I previously mentioned. Clients often prefer one type over the other. JSON, for example, is often preferred over XML, as it's less verbose and thus faster to transfer. The relative quality factor allows us to indicate preference. Let's have a look. We added two values to the accept header of the last request we sent in the demo, application JSON and application XML. From that, it follows that the accept header looked as you see on screen now. What this means is that we accept both with equal preference, which is a preference of 1. That's the maximum. Via the relative quality parameter, we can indicate preference between 0 and 1. For example, when we indicate we want to accept XML with a preference of 0.9, the Q parameter gets value 0.9. This accept header would, in our case, have resulted in JSON being returned, even though XML is the default for our API. And that's because the default value for the relative quality parameter is 1, and the media type associated with the highest value wins. So what we wrote here is the same as giving Q a value of 1 for application JSON and a value of 0.9 for application XML. Important side note though, to allow this to work, the API must support it, and not every API does. But APIs built with ASP.NET Core support this out of the box. So let's have a look. In this demo, we will indicate that we support both XML and JSON, but prefer JSON. To achieve this, it's a matter of using the correct media type with quality header value constructor overload. If we don't input a quality, the default preference value is 1. So let's leave it as is for application JSON, and let's set it to 0.9 for application XML. And let's give this a try. Let's set breakpoints in the code where we check the media type of the response. and we hit the breakpoint that will result in the JSON deserializer being used. Let's continue, and that seems to have worked. So there we go. We get back JSON, but we still support XML as a fallback option. Now let's think about how we are setting these headers. We're using default request headers, which means that we have set it for all our requests. But what if we want to use some headers for some requests and other headers for other requests? But these days, APIs are using vendor-specific media types more and more as a version strategy to diversify between different resource versions. Or, for example, to allow fetching a resource with or without HTOS links. In that case, application JSON doesn't cut it anymore. So I would be tempted to write code as you see on screen now to manipulate these headers before each call. And this will work, as long as these requests are fired one by one, and we don't continue with the next request before the previous one is done. But imagine that we're using this one instance across our application, on different screens, for example in a Xamarin app, where you might have offloaded fetching data to a different thread, or in different data services in an ASP.NET Core app. HTTP client itself is thread safe, but not all the properties we use for configuration are. And that can cause some nasty bugs that are very hard to reproduce or identify. So this is not the way to go. Let's get rid of that code here, and let's check out an approach that does work.